Hello everybody, this is Shankar from System Based Labs. In the previous video, we discussed overfitting. We saw how models can memorize data and fail to generalize. Now we move into something even more critical. A model that does not just fail, but behaves unfairly. This problem is called bias. Let's understand this simply. A machine learning model learns from data. If the data is balanced and representative, the model learns fairly, but if the data is skewed, incomplete, or one-sided, the model learns those same biases. And then it starts making unfair decisions. Let's take a simple example. Suppose in your training data, most high-income customers are marked as default. The model learns high income means risky. Now when a new customer comes in, good income, good credit score, the model may still reject them. This is not random error, this is systematic bias. And here is the danger. Bias is consistent. It repeats across similar cases. Now think like a tester. If one case fails, it may be a defect. But if a pattern of cases fails, it is bias. That is the key difference. Now let's connect this to your earlier learning. Bias affects sensitivity and specificity. Example, if a model favors one group, sensitivity may drop for another group. False negatives increase. This means the model is blind to certain risks. In other cases, false positives increase. The model overreacts to certain profiles. Now connect this to real-world impact. In healthcare, bias may cause certain patients not being diagnosed. In banking, bias may cause certain customers always being rejected. This is not just a technical issue, this is a business risk and sometimes a regulatory violation. Now connect this to SQAAF trademark. SQAAF trademark, Software Quality Assurance and Validation in AI Framework, treats bias as a validation failure because bias originates from training data, feature selection, and model behavior. SQAAF trademark asks, is the data representative? Are all groups fairly evaluated? Are predictions consistent across profiles? If not, the system cannot be trusted. As a tester, you must test across multiple data groups. Compare outputs for similar profiles. Look for repeating patterns of failure. Do not test only one case. Test categories. Test distributions. Because bias is not visible in a single result. It appears in patterns. Machine learning models do not create bias. They learn it, and if you do not detect it, they will repeat it. In traditional testing, you check correctness. In AI testing, you check fairness and consistency. This is Shankar from System Based Lab. Good luck and goodbye.